Hey there, Kimmer here. Today we're going to talk a little bit about formatting output. This is not an exhaustive list, but it'll get you moving pretty quickly. So let's get started. First thing we're going to do is take a look at a program. I have a program that I've already started. Notice that it starts with some integers, and I just labeled these W, X, Y, and Z. Now, just for the record, those are really horrible variable names. Don't ever use them. I'm just using them quickly here to show you an example of something. If I were writing an actual application, I would not use W, X, Y, and Z for variables like this. Okay, so let's just take a look at what I've done here. First of all, if you don't know, I gave the variables a value at the time I declared them, so that is called initializing. So I went ahead and initialized W to 12, X to 345, Y to 6,789, and Z to 1,011. Now, if you look, I was just putting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so notice I have 4 different printfs. And in each one of these printfs, I just put my %d because that's my integer I'm going to display as a decimal integer. And here I go. So when I go ahead and compile and run this particular program, here's the output that you see. You'll notice, even though I have these on 4 separate printf lines, it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It prints them all together. Okay, so let's talk about why that happens. Okay, so the printf function will print its output without any regard for any new lines or spacing or perhaps in some cases make it very difficult to print certain characters. So we're going to talk about some of these common escape sequences. It's, like I said, not an exhaustive list, but it'll get you moving. So the very first one is the \n. Okay, and that stands for a new line. You'll notice in all of these, there's a backslash in each and every one. That, as soon as it sees a backslash inside of a string, and we'll talk about that in a minute, it'll look at the letter following, or I should say the character following, and know what to do. So \n stands for a new line. If we jump back over to our code, and I put in a \n. Now notice where I'm putting this \n. I'm putting it on the inside of the string. So if I put \n here, it's the equivalent of me hitting the Enter key. So if I go ahead and close this, run the program again, compile and run, I should say, you'll notice now each one of those went to a new line. There's my 12, 345, 67, 89, and 10, 11. New line, new line, new line, new line. So some people like to put them in the front. Some people prefer to put them in the back. And there's reasons for doing each of those. For right now, I just want you to use them where you feel you need to. And eventually you'll learn when to put them in the front and when to put them in the back. Okay. So let's move forward. You will notice with these new lines, we used integers, so you're used to using the %d. I get that. But notice there's a couple different forms that we can use. So we're going to try putting tens in front of the d. This is a field width. Let's take a look at those. So in between the % and the d, I'm going to go ahead and throw in a 10 on each one of these. Now basically what I'm saying is I want this particular integer to take up a total of 10 spaces. Now obviously 12 doesn't take up 10 spaces. So watch what it does. I'm going to save it, compile it, and there you go. You'll notice it starts and it right aligns or right justifies, but it uses a field width of 10 spaces. Let's take that another step further. Watch what happens if I decide to add, I'll just add it to this one, a 0.5. Now there's no decimal points in an integer. So when we use it in an integer, this is going to tell us to use significant digits, to telling us how many significant digits to display. And I'll show you what that does. Since we told the second line to display at least 5 significant digits, you'll see that it shows me my 3, but because we told it we wanted 5, it throws in some leading zeros. So this is one way. There's another way. We'll show you in just a minute. But this is one way of getting leading zeros into an output, if you will. All right, let's take a look at another one. So what if we had 0.5 here, but this time we're going to put a minus sign in front. Okay, so we have minus 10.5. 10 is still our field width. The 0.5 on an integer will tell it how many significant digits to show, but the minus sign does something just a little bit different. See if you can figure it out. We did the minus over here. Notice how it typically right justifies. If we want to force it to left justify, then we go ahead and put a minus in front of it. Okay? So those are some ways that we can format our integers, and we can put with specifiers. So if our integers are of different sizes, we can go ahead and have those line up the way that we want them to. Now, let's take a look at floating points. So I'm going to assume at this point that you know what a float variable is. And just in case, a quick little reminder, a float variable is a number that contains a decimal point, even if that decimal point is 0.0. As soon as you see the decimal point, you know it's a float. So let's put some code up for that. Okay, we're going to take a quick look at this next program. So this next program declares 4 floating point variables, one called num1, the other called num2, the other called sum, the other called product. Now what I'm going to show you here will also work for doubles as well, or long floats. So, but you can use them for either or. So I'm just going to use floats in this case right here. So if we go ahead, you'll notice that it asks, prompts the user to enter in a number, prompts the user to enter in another number, adds them, and multiplies them to get the sum and the product, and then it prints the sum of your numbers is, prints the sum, the product of your numbers is, prints the product. So watch what happens when we run it. So we're going to enter a number. I'm just going to pick the number 22 and another number 5. Now, always know when you give test data, always know what your output should be. So if we add these two numbers together, we should see, what, 27. And if we multiply these two together, we should see 110. So let's make sure that those are what we're seeing. Now you'll notice it says the sum of your numbers is 27.000000. The product of your numbers is 110.000000. Also, all on one line, even though our output has 2 printfs. But we already know how to fix that. So let's go ahead and fix just that. We can put backslash n's. I'm going to put them in front for now. And I'm going to run it again, just so that you can see this work. Using my same numbers. I don't want to change up my numbers if I'm just testing something. Notice how now it moves it down to 2 different lines. But I still have all these zeros here that maybe I don't want. Assuming that we're dealing with money and we only want 2 decimal places, we're going to tell this %f that we want to use 0.2. 0.2. So this is telling us now it worked differently when we did it with a decimal. Remember, that was significant digits. Now we're going to say, this is how many decimal points I want to show up. So let's go ahead and run it again using the exact same data. And notice now I don't see all those zeros, but instead I see 2. I could put 0.1. Technically, I can put 0.0. I could put 0.10. We'll run into problems when you start getting too big, but that's for another video. Okay. So we're able to then tell it to only display a certain number of decimal points. Okay. So the next thing that I would like to do is to show you how you can change up these numbers. So I think what I'm going to do is I am going to copy these 2 lines, and we're going to paste them. Okay, so we're going to see the numbers again, but I just want you to see the differences. Okay. So in this case, if I put a number, say, before the 2, such as an 8, okay, now that is my field width. But you have to be very careful about your field width when it comes to floats or any kind of floating point. So let's go take a look at what this does. Again, my number is 22 and 5. Okay. So you're probably not noticing too much here in too much here, but this is the reason why I wanted to show you both of them. Is notice there was only one space here, but there's more spaces here and there's more spaces here. Okay. Let's take a look at this next part. I can tell it to put in leading zeros, and I'm going to do this because I want you to see the actual spaces. This is the important part of the number 8. It doesn't have to be 8, it can be whatever you want. Remember, that is a field width. In the %Ds we chose, we did a 10. I'm going to go ahead, throw in my 22 and my 5. Now remember, we had an 8. 8.2. So in this case, do you see 8 primary significant digits here? You do not. You see 5. So what I want you to realize is with the 8, or whatever number you decide to use, okay, it is the total number of spaces for the field, hence the field width, including the decimal point. So when we just said 8, think about this. 1, 2, 3, 4, 5. The decimal point counts 6, then the 2 zeros are 7, 8. Okay, that is your field width. All right, so let's show you the next thing. Okay, if we take a look at this next program, you'll notice that I have 2 integer variables here, one called sigdig, which I'm having it stand for significant digits, and the other called desc_places, which I'm referring to as 2 decimal places. So we can, you'll notice right now I only have 1% f, and an integer, and a float. So, but what I'm going to do is I'm going to say, you know what, sometimes I may not know exactly how many significant digits or how many decimal places that I want to show. So therefore, I'm going to use these variables. And that's kind of just what I want you to see, is you can use these variables to show the significant digits or how many decimal places. So if somebody wants 3 decimal places or 8, you can ask them how many they would like to have it displayed. And then, of course, here's my number. So let's display 3, 4, 5, 6. Let's just add a couple, only because I want to show you something else. So if I take this particular program, compile it, run it, you'll notice a couple of things. First of all, did you notice that even though my thing was 12.3456, it actually showed only 3.5. It actually rounded because I said my decimal places I wanted was 0.2. So order matters. The first one is for the first asterisk. The second one is for the second asterisk. They have to be integers. And I could have actually just put hard-coded numbers, but if I'm going to hard-code numbers, I might as well just hard-code them in place of this. So this is only usually used when you want to do something with you know, the user decides or another program might decide. So the other thing I want you to notice is because it's basically saying to take this number and show it using 2 decimal places, it actually rounds up. Now, it's kind of hard to see how many places or the fact that it actually did move over 8 by 8. So one thing I'm going to do is I'm going to just throw in little arrows here. I could have thrown in anything, okay? Dashes, dots, whatever. I'm just doing this to show you the in-between. So when we go ahead and close this and run it again. Let's close it. Let's go ahead and save it and compile. You can then kind of see where it shows up, and you'll notice that it's 8, 1, 2, 3, 4. Believe it or not, there's 5, 6, 7, 8. So you can kind of see how we did that. What do you think is going to happen if we put a 0 right here? Let's try. Right? So 1, 2, 3, 4, 5. Don't forget the decimal place counts as a space. 6, 7, and 8. So you can kind of see how you can go ahead and do that. That's kind of a neat little trick. Okay, a couple more things to show you and then we'll be done. Okay, let's take another look at output in a printf. This one you'll notice that I have some variables x, y, and then I'm having the sum and product, so it's very similar to the one we just did. But sometimes people call sum addition, and sometimes people call product multiplication. So I want my output to reflect that. I want it to say the sum/addition of your numbers is. So you'll notice that I put in this slash here. If I go ahead and compile it, you will notice you'll have to look at the bottom here, but you will notice that I have an error. Actually, I don't have an error. I have a warning, and it's going to ignore me, but in a lot of cases, you might have an error. So this is an unknown escape sequence. Because it sees a backslash, like it does in the backslash n, it thinks that this next letter, well, A actually stands for something, M, however, does not. So all of a sudden it's saying, I don't know what this M is supposed to do. I know what the backslash n does, and I technically know what the backslash A does. By the way, that means alert, a little beep sound, if you want to ever throw that in there. But in this case, it doesn't know what a backslash M is, so it has an error. If we take a look at this screen again, we see some other escape sequences. So notice if I want a backslash to show up, I have to actually include another backslash. So let's go ahead and do that. Take a look at our code. So we're going to double this up and double that up, and we're going to compile and run it. And now when we run it, you'll see that it actually puts the slash in. If we go back and take a look at here, the same thing happens for a double quote or a single quote. Because a double quote, if we were to put in a double quote here, let's try this, and let's try this. Do you see how it's basically telling us, hey, I don't know what this is, or it will actually. Probably, I don't know if you can see the numbers, or the colors, excuse me. But if I want it to kind of show up like this and I try to compile, it's going to say, no, you can't do that. See, I get all these errors. So, backslash, 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 backslash. Let's go ahead and compile it again. Let's run it again. And now it shows up in my output. Okay. I believe that just about does it, at least for now. I mean, like I said, this wasn't everything, but this should get you going pretty well, I believe, when it comes to formatting our output, which you should always do. Your output should look nice for the users. Okay, we will talk soon.